Good day everyone! Welcome to Math with Teacher Justin. On today's topic, we're going to talk about solving missing parts of similar triangles. Alright. Okay, before we proceed to solving missing parts of similar triangles, let's define first what is triangle similarities. So if two triangles are similar, then the corresponding angles are congruent and the corresponding sides are proportional. So for this example, for these two triangles, if triangle PBL is similar to triangle COD, then their angles, their corresponding angles are congruent and their corresponding sides are proportional. Alright, now that we know the definition of triangle similarities, let's proceed to some examples in solving triangle similarities. Now let's have our given. Solve for the value of x given that triangle YUN is similar to triangle GUM. Now we're given these two triangles, YUN and GUM. Now let's identify their corresponding sides. Okay, knowing that they are similar, we must have pairings of corresponding sides. So let's identify their corresponding sides. So we can say that side YN corresponds to side GM, YU corresponds to GU, and NU corresponds to UM. But we are not going to use that anymore because we are only focusing on the given parts of the triangle. Okay, and knowing that these two triangles are similar, we can say that the corresponding sides are proportional. So we can form an equation, and our equation will be YN over GM is equal to YU over GU. Now let's substitute the measurement of each side. We will have 9 over 7 is equal to x over 21. Now let's solve for the value of x by isolating the variable x, and let's multiply both sides by 21. So multiplying both sides by 21 and simplifying it, we will have 27. So again, we simplify. So x will be equal to 27. Alright. Okay, let's have another example. So for example, we're going to solve for the value of x, given that triangle AVP is similar to triangle ETP. Now here we have two triangles, AVP and ETP, and we're solving for the value of x, that is the measurement of side AV. Before we proceed to our computation, we have to identify our corresponding sides. Knowing that they are similar triangles, we will have corresponding sides. We can say that side AP corresponds to side EP and side AV corresponds to side ET. Okay, so we know that similar triangle has corresponding sides that are proportional. Therefore, we are going to formulate our equation. We will have AV over ET is equal to AP over EP. Now, let's substitute the value of our sides to our equation. So AV is x, ET is 8, AP is 18, and EP is 6. Now take note, our AP is the sum of side AE and EP. So 12 plus 6, that is equal to 18. So we will have x over 8 is equal to 18 over 6. We can simplify our given fraction. So we will have x over 8 is equal to 3. Now let's solve for the value of x by multiplying both sides by 8. And x will be equal to 24. Alright. Okay, let's have another example. So for example, we're going to solve for the value of x and y given that triangle KEY is similar to triangle DIP. So knowing that we have similar triangles, we have to identify our corresponding sides. So our corresponding sides are KE corresponds to DI, EY corresponds to side IP, KY corresponds to DP, and we know that for similar triangles, corresponding sides are proportional. Okay, so we will formulate our equation, which is KE over DI is equal to EY over IP is equal to KY over KP. Now, let's substitute the value of each side. We will have 4 over 2 is equal to Y over 7 is equal to X over 5. Now, let's try to solve for the value of Y first. So, Y over 7 is equal to 4 over 2. Okay, let's pair one of the variable with the complete fraction, which is 4 over 2. So, Y over 7 is equal to 4 over 2. Now, let's simplify 4 over 2. That is equal to 2. Then, let's solve for the value of Y by multiplying both sides by 7. So, Y is equal to 14. Okay. Now, let's proceed to solving for the value of X. So, X over 5, we equate it to another complete fraction, which is 4 over 2. So, X over 5 is equal to 4 over 2. So, let's simplify 4 over 2. We will have X over 5 is equal to 2. And let's solve for the value of X by multiplying both sides by 5. That will be our final answer. Alright, okay, let's have another example. So for example, we're going to solve for the value of X and Y given that triangle HOP is similar to triangle DNA. Okay, so knowing that we have similar triangles, we can first identify the corresponding sides. So we can say that side HP corresponds to side DA, and side PO corresponds to side AN, and then side HO corresponds to side TN. Okay, since we have similar triangles, we can say that corresponding sides are proportional. So we can formulate our equation. DP over DA is equal to DO over AN is equal to HO over TN. So let's substitute the value of each side. So we have Y over 2 is equal to 6 over 4 is equal to X over 3. Then from there, we can now solve for the value of X and Y. So let's start first with the variable Y. So let's equate Y over 2 to 6 over 4. So let's multiply both sides by 2. We will have Y is equal to 3. Then let's proceed to solving for the value of X. Now again, we will just pair X over 3 to our complete fraction 6 over 4. Okay, then we multiply both sides by 3. Then simplify, we will have X is equal to 9 over 2, which is 4.5. Okay, so our dimension for X and Y will be 4.5 and 3. Alright, so let's have our last example for today. Solve for the value of X and Y, given that triangle GRA is similar to triangle ART. Okay, so here we have two triangles, two right triangles. Okay, so let's identify their corresponding sides. So for side GR, it corresponds to side AR, side GA corresponds to side AT, and AR corresponds to side RT. Alright, so since they are similar triangles, we can say that their corresponding sides are proportional. So we can formulate our equation. GR over AR is equal to GA over AT is equal to AR over RT. Alright, then let's substitute our given. We have Y over 4 is equal to X over 5 is equal to 4 over 3. Now, to solve for the values of X and Y, we're going to isolate them and pair them to a complete fraction without any variable. So, Y over 4 is equal to 4 over 3. So, let's solve for the value of Y by multiplying both sides by 4. We will have Y is equal to 16 over 3, which is approximately equal to 5.33. Now, let's solve for the value of X. Same procedure. We're going to equate X over 5 to 4 over 3, a complete fraction. So, let's solve by multiplying both sides by 5 and then simplifying it. We will have X is equal to 20 over 3, which approximately be equal to 6.67. Alright, so that will be our value of x and y. Now that you already know how to solve missing parts of similar triangles, it is your turn to try it. Please click the link in our description box below in order for you to test your skills. That's it for today. Again, I'm Teacher Justin. Goodbye, God bless, and stay safe. See you on my next video. Peace!